Chapter 9: The Debates, Progress, and Likely Future Paths of AI. Part 1. Over the last number of decades, we have seen AI's impact, progress, and future direction being debated and discussed on so many different levels. AI research going through several rough winter and blossoming summer periods, actually all seasons of a year, as well as a variety of AI narratives, ideas, and perspectives of AI's likely future paths. As we are making scientific and engineering progress as humanity, we are steadily and surely getting better at building a rich and powerful toolbox of AI algorithms, structures, and techniques, along with its software and hardware infrastructure for research and applications. We're also getting better at understanding the dynamics, power, nature, complexity, and inner workings of AI and intelligence in a broader sense. In this chapter, these aspects will be explored in more detail to assist us in developing a more realistic, practical, and thoughtful understanding of AI's progress and likely future paths that we can use as input to help shape a beneficial, human-centric future. Making sense of the AI debates. The debates about AI's future path and impact on humanity is like a roller coaster ride of thoughts and ideas from so many different perspectives, driven by a mix of fear and excitement about the enormous risks and opportunities that AI presents this century and beyond. As AI can be put firmly in the bracket of powerful enough technology that gives life the potential to flourish like never before or to self-destruct, as described by the Future of Life Institute, the debates around AI and other smart technologies are becoming one of the most important discussions of our time. Even with narrow AI systems that may accomplish a narrow set of goals at least as well as humans, these systems can in its own right, or even within a connected network of such systems, be powerful and impactful enough to create havoc or help humanity to thrive. In Nick Bostrom's Superintelligence Paths, Dangers, Strategies, he reasons that strong AI in the form of intelligent machines that can match or outperform humans on any cognitive task and improve their capabilities at a faster rate than humans could potentially lead to an existential nightmare for humanity. He specifically believes that for such a strong AI to dominate, it would need to master skills such as intelligence amplification, strategizing, hacking, social manipulation, economic productivity, and technology research. Max Tegmark in Life 3.0 sees strong AI as a third stage of life, where technology designs its hardware, matter made of atoms, and software, information made of bits, as opposed to the first stage, which is simple biological life that can only survive and replicate through evolving its hardware and software, information encoded in, for example, DNA, and the second stage, which is more cultural, where life can evolve its hardware, physical body, but also design its software, such as humans learning new skills and knowledge and changing perspectives, goals, and worldviews, Life 2.0. As today's humans can perform minor hardware upgrades with, for example, implants, Max reckons that we are probably at a 2.1 level. According to the Future of Life Institute, most disputes amongst AI experts and others about strong AI that potentially have Life 3.0 capabilities revolves around when and or if ever it will happen, and will it be beneficial for humanity. This leads to a classification where we have at least 4 distinct groups of thinking about where we are heading with AI, which are the so-called Luddites, technological utopians, techno-skeptics, and the beneficial AI movement. Whereas Luddites, within this context, are opposed to new technology such as AI and especially have very negative expectations of strong AI and its impact on society. Technological utopians sit on the other end of the spectrum with very positive expectations of the impact of advanced technology and science to help create a better future for all. The techno-skeptics do not think that strong AI is a real possibility within the next 100 years, and that we should focus more on the shorter-term impacts, risks, and concerns of AI that can have a massive impact on society, as also described in the previous chapter. The beneficial AI group of thinkers are more focused on creating safe and beneficial AI for both narrow and strong AI, as we cannot be sure that strong AI will not be created this century and it is anyway needed for narrow AI applications as well. AI can become dangerous when it is developed to do something destructive or harmful, but also when it is developed to do something good or advantageous, but use a damaging method for achieving its objective. So even in the latter case, the real concern is strong AI's competence in achieving its goals that might not be aligned with ours. Although my surname is Ludic, I'm clearly not a Luddite and would consider my own thinking and massive transformative purpose to be more aligned with the beneficial AI group of thinkers and currently more concerned with the short to medium term risks and challenges and practical solutions to create a beneficial world for as many people as possible. Prominent business leaders, scientists, and influencers such as Elon Musk, the late Stephen Hawking, Martin Rees, and Eliezer Yudkowsky have issued dreadful warnings about AI being an existential risk to humanity, whilst well-resourced institutes countering this doomsday narrative with their own AI for good or beneficial AI narrative. AI researcher and entrepreneur Andrew Ng has once said that fearing a rise of killer robots is like worrying about overpopulation on Mars. That has also been countered by AI researcher Stuart Russell, who said that a more suitable analogy would be working on a plan to move the human race to Mars with no consideration for what we might breathe, drink, or eat once we arrive. Many leading AI researchers seem to not identify with the existential alarmist view on AI, are more concerned about the short to medium term risks and challenges of AI discussed in the previous chapter, think that we are still at a very nascent stage of AI research and development, do not see a clear path to strong AI over the next few decades, and are of the opinion that the tangible impact of AI applications should be regulated, but not AI research and development. Most AI researchers and practitioners would fall into the beneficial AI movement and/or technoskeptics category. Oren Etzioni, CEO of Allen Institute for Artificial Intelligence, wrote an opinion article titled How to Regulate Artificial Intelligence, where he claims that the alarmist view that AI is an existential threat to humanity confuses AI research and development with science fiction, but recognizes that there are valid concerns about AI applications with respect to areas such as lethal autonomous weapons, jobs, ethics, and data privacy. From a regulatory perspective, he proposes 3 rules that include that AI systems should be put through the full extent of the laws that apply to each human operator, must clearly reveal that they are not a human, and cannot keep or reveal confidential information without clear approval from the source of that information. Some strong technological utopian proponents include roboticist Hans Moravec, as communicated in his book Mind Children, The Future of Robot and Human Intelligence, as well as Ray Kurzweil, who is currently Director of Engineering at Google and has written books on the technology singularity, futurism, and transhumanism, such as The Age of Spiritual Machines and The Singularity is Near, When Humans Transcend Biology. The concept of a technological singularity has been popular in many science fiction books and movies over the years. Some of Ray's predictions include that by 2029, AI will reach human-level intelligence, and that by 2045, the pace of change will be so astonishingly quick that we won't be able to keep up unless we enhance our own intelligence by merging with the intelligent machines we are creating. There are a number of authors, AI thought leaders, and computer scientists that have criticized Kurzweil's predictions in various degrees from both an aggressive timeline and real-world plausibility perspective. Some of these people include Andrew Ng, Rodney Brooks, Francia Chollet, Bruce Sterling, Neil Stevenson, David Gelinter, Daniel Dennett, Maciej Seglovsky, and the late Paul Allen. Web developer and entrepreneur Maciej Siglovsky calls superintelligence the idea that eats smart people and provides a range of arguments for this position in response to Kurzweil's claims, as well as Nick Bostrom's book on superintelligence and the positive reviews and recommendations that the book got from Elon Musk, Bill Gates, and others. AI researcher and software engineer Francois Cholet wrote a blog on why the singularity is not coming, as well as an article on the implausibility of an intelligence explosion. He specifically argues that a hypothetical self-improving AI would see its own intelligence stagnate soon enough rather than explode due to scientific progress being linear and not exponential, as well as also getting exponentially harder and suffering diminishing returns, even if we have an exponential growth in scientific resources. This has also been noted in the article Science is Getting Less Bang for Its Buck, that explores why great scientific discoveries are more difficult to make in established fields, and notes that the emergent levels of behavior and knowledge that lead to a proliferation of new fields with their own fundamental questions seems to be the avenue for science to continue as an endless frontier. Using a simple mathematical model that demonstrates an exponential decrease of discovery impact of each succeeding researcher in a given field, Francois Cholet concludes that scientific discovery is getting harder in a given field, and linear progress is kept intact with exponential growth in scientific resources that is making up for the increased difficulty of doing breakthrough scientific research. He further constructs another model with parameters for discovery impact and time to produce impact, which shows how the rate of progress of a self-improving AI converges exponentially to zero unless it has access to exponentially increasing resources to manage a linear rate of progress. He reasons that paradigm shifts can be modeled in a similar way with the paradigm shift volume that snowballs over time and the actual impact of each shift decreasing exponentially, which in turn results in only linear growth of shift impact, given the escalating resources dedicated to both paradigm expansion and intra-paradigm discovery. Francois states that intelligence is just a meta skill that defines the ability to gain new skills and should be, along with hard work, at the service of imagination, as imagination is the real superpower that allows one to work at paradigm level of discovery. The key conclusions that Francois makes in his article on implausibility of intelligence explosion are firstly that general intelligence is a misnomer, as intelligence is actually situational, in the sense that the brain operates within a broader ecosystem consisting of a human body, an environment, and a broader society. Furthermore, the environment is putting constraints on individual intelligence, which is limited by its context within the environment. Most of the human intelligence is located in a broader self-improving civilization intellect where we live and that feeds our individual brains. The progress in science by a civilization intellect is an example of a recursively self-improving intelligence expansion system that is already experiencing a linear rate of progress for reasons mentioned above. In the essay The 7 Deadly Sins of Predicting the Future of AI, Rodney Brooks, who is the co-founder of iRobot and Rethink Robotics, firstly quotes Amar's law that we tend to overestimate the effect of a technology in the short run and underestimate the effect in the long run, to state that the long-term timing for AI is being crudely underestimated. He also quotes Arthur C. Clarke's third law that states that any sufficiently advanced technology is indistinguishable from magic, to make the point that arguments for a magical future AI are faith-based, and when things said about AI that are far enough from what we use and understand today and for practical purposes passes the magic line, those things cannot be falsified. As it is also intuitive for us to generalize from the observed performance level on a particular task to competence in related areas, it is also natural and easy for us to apply the same human-style generalizations to current AI systems that operate in extremely narrow application areas and overestimate their true competence level. Similarly, people can easily misinterpret suitcase words applied to AI systems to mean more than what there actually is. Rodney also argues that as exponentials are typically part of an S-curve where hypergrowth flattens out, one should in general be careful to apply exponential arguments, as it can easily collapse when a physical limit is hit or if there is not sufficient economic value to persist with it. The same holds for AI, where deep learning success, which can also be seen as an isolated event and achieved on top of at least 30 years of machine learning research and applications, does not necessarily guarantee similar breakthroughs on a regular basis. Not only is the future reality of AI likely to be significantly different to what is being portrayed in Hollywood science fiction movies, but also have a variety of advanced intelligence systems that evolve technologically over time in a world that would be adapting to these systems. The final error being made when predicting the future of AI is that the speed of deploying new ideas and applications in robotics and AI take longer than people think, especially when hardware is involved, as with self-driving cars, or in many factories around the world that are still running decades-old equipment along with the old automation and operating system software. On the self-driving cars front, both Tesla and Google's Waymo have improved self-driving technology significantly, with Waymo achieving feature-complete status in 2015 but in geo-fenced areas, whereas Tesla is at almost zero interventions between home and work, with an upcoming software release promising to be a quantum leap in 2020. However, the reality is that Tesla's full driving autopilot software is progressing much slower than what Elon Musk predicted over the years, and Chris Urmson, the former leader of Google's self-driving project and CEO of self-driving startup Aurora, reckons that driverless cars will be slowly integrated over the next 30 to 50 years. Piero Scaruffi, a freelance software consultant and writer, is even more of a techno-skeptic and wrote in Intelligence is Not Artificial, Why the Singularity is Not Coming Anytime Soon, and other meditations on the post-human condition and the future of intelligence, that his estimate for superintelligence that can be a substitute for humans in virtually all cognitive tasks, including those requiring scientific creativity, common sense, and social skills, to be approximately 200,000 years, which is the timescale of natural evolution to produce a new species that will be at least as intelligent as us. He does not think that we'll get to strong AI systems with our current incremental approach, and that the current brute force AI approach is actually slowing down research in higher level intelligence. He guesses that an AI breakthrough will likely have to do with real memory that have recursive mechanisms for endlessly remodeling internal states. Piero disagrees with Ray Kurzweil's law of accelerating returns and points out that the diagram titled Exponential Growth in Computing is like comparing the power of a windmill to the power of a horse and concluding that the windmills will keep improving forever. There is also no differentiation between progress in hardware versus progress in software and algorithms. Even though there has been significant progress in computers in terms of its speed, size, and cost-effectiveness, that does not necessarily imply that we will get to human-level intelligence and then superintelligence by assembling millions of super-fast GPUs. A diagram showing exponential growth in computational math would be more relevant and will show that there has been no significant improvement in the development of abstract algorithms that improve automatic learning techniques. He is much more impressed with the significant progress in genetics since the discovery of the double helix structure of DNA in 1953 and is more optimistic that we will get to superhuman intelligence through synthetic biology. A survey taken by the Future of Life Institute says we are going to get strong AI around 2050, whereas one conducted by Singularity Net and Good AI at the 2018 Joint Multi-Conference on Human-Level AI shows that 37% of respondents believe human-like AI will be achieved within 5 to 10 years. 28% of respondents expected strong AI to emerge within the next 2 decades, while only 2% didn't believe humans will ever develop strong AI. Ben Goodsill, Singularity Net CEO and developer of the software behind a social humanoid robot called Sophia, said at the time that it is no secret that machines are advancing exponentially and will eventually surpass human intelligence. And also, as these survey results suggest, an increasing number of experts believe this singularity point may occur much sooner than is commonly thought. It could very well become a reality within the next decade. Lex Friedman, AI researcher at MIT and YouTube podcast host, thinks that we are already living through a singularity now and that superintelligence will arise from our human collective intelligence instead of strong AI systems. George Hotz, a programmer, hacker, and the founder of Comma.ai, also thinks that we are in a singularity now if we consider the escalating bandwidth between people across the globe through highly interconnected networks with increasing speed of information flow. Jürgen Smithuber, AI researcher and scientific director at the Swiss AI lab ITSEA, is also very bullish about this, and that we soon should have cost-effective devices with the raw computational power of the human brain, and decades after this, the computational power of 10 billion human brains together. He also thinks that we already know how to implement curiosity and creativity in self-motivated AI systems that pursue their own goals at scale. According to Jürgen, superintelligent AI systems will likely be more interested in exploring and transforming space and the universe than being restricted to Earth. AI Impacts has an AI Timeline Surveys webpage that documents a number of surveys where the median estimates for a 50% chance of human-level AI vary from 2056 to at least 21,006, depending on the question framing and the different interpretations of human-level AI, where two others had medium estimates at the 2050s and 2085. Rodney Brooks has declared that artificial general intelligence has been delayed to 2099 as an average estimate in a May 2019 post that references a survey done by Martin Ford via his book Architects of Intelligence, where he interviewed 23 of the leading researchers, practitioners, and others involved in the AI field. It is not surprising to see Ray Kurzweil and Rodney Brooks at opposite ends of the timeline prediction, with Ray at 2029 and Rodney at 2200. Whereas Ray is a strong advocate of accelerating returns and believes that a hierarchical connectionist-based approach that incorporates adequate real-world knowledge and multi-chain reasoning in language understanding might be enough to achieve strong AI. Rodney thinks that not everything is exponential and that we need a lot more breakthroughs and new algorithms, in addition to backpropagation used in deep learning, to approximate anything close to what biological systems are doing, especially given the fact that we cannot currently even replicate the learning capabilities, adaptability, or the mechanics of insects. Rodney reckons that some of the major obstacles to overcome include dexterity, experiential memory, understanding the world from a day-to-day perspective, comprehending what goals are, and what it means to make progress towards them. Ray's opinion is that technoskeptics are thinking linearly, suffering from engineers' pessimism, and do not see exponential progress in software advances and cross-fertilization of ideas. He believes that we will see strong AI progresses exponentially in a soft takeoff in about 25 years. Other people included in Martin Ford's survey were Yoshua Bengio, University of Montreal, Jan LeCun, Facebook, Jeffrey Hinton, University of Toronto and Google, Stuart Russell, UC Berkeley, Oren Etzioni, Allen Institute for AI, Gary Marcus, NYU, Demis Hassibis, DeepMind, Fifi Lee, Stanford and Google, Andrew Ng, AI Fund, Daphne Koller, Stanford, Nick Bostrom, University of Oxford, Barbara Gross, Harvard, David Ferrucci, Elemental Cognition, James Manyika, McKinsey, Judea Pearl, UCLA, Josh Tenenbaum, MIT, Rana L. Kaliubi, Effectiva, Daniela Russ, MIT, Jeff Dean, Google, Cynthia Breeziel, MIT, and Brian Johnson, Kernel. Having been deeply involved in AI research and its applications over the years and having a good understanding of the current state of the art in the full AI toolbox, my current guesstimate for human-level AI is likely also in the second half of this century. When asked by Martin Ford about research breakthroughs needed to get to strong AI, Yoshua Bengio responded by saying that we are far away and first need to solve really hard problems, such as AI not currently being able to understand the world as well as we do, acquiring knowledge of the world in an unsupervised autonomous fashion, and missing key components such as the ability to understand and infer causal relationships in data. He, along with Jan LeCun, envisage AI research into the future as being like climbing a hill, making a breakthrough as you reach the top, which is not guaranteed and can take many years, seeing the limitations of the new approach or discovery, and continuing to the next hill as part of a series of hills ahead. According to Jan, one of those hills to climb out will be to figure out how babies and animals learn via unsupervised learning methods, which might take 10 or 20 years. As we can expect several problems like this to solve, it could take 50 to even 100 years to get to strong AI. Both Yoshua and Jan are not concerned at this point with recursively improving superintelligent AI or that it poses an existential threat for humanity. Although it is fine that these questions are studied, Yoshua does not see this to be realistic or even compatible with the type of AI being built right now and for the foreseeable future. Jan also disagrees strongly with the existential alarmist view of AI, in particular Nick Bostrom's fast takeoff scenario with recursive self-improving at an exponential rate. Similar to Francois Chollet's earlier arguments, the singularity and fast takeoff scenario ignore, for example, friction such as exhausting resources and key elements that govern the progress of AI, its level of sophistication, the economy, consumption of resources, and communication. Like many other researchers, they are more concerned about the short-term potential risks with respect to lethal autonomous weapons, jobs, and economic issues, minimizing distress and optimizing well-being, biased and reinforced discrimination, political advertising, and governmental surveillance of citizens. However, Jan LeCun disagrees with Stuart Russell and the Future of Life Institute that the use of AI-powered weapons can potentially lead to mass destruction. He thinks that militaries will likely use AI-driven drones for surgical types of operations, where people can be taken out in a non-lethal fashion. There are also other types of debates amongst AI researchers that emphasize different approaches to advance the state-of-the-art in AI. Whereas researchers such as Yoshua, Jan, and Jeff Hinton favor working with neural network type of approaches that focus on learning methods for supervised and self-supervised learning that are not necessarily dependent on specific structures, although that plays an important role with current learning methods such as backpropagation. Researchers such as Gary Marcus and Oren Etzioni are working on bringing in hybrid structures that can deal with symbolic methods for logic and reasoning. Joshua and Gary also had an interesting debate in Montreal in December 2019 about their different approaches, where they agreed that AI systems need a hybrid approach with priors and high-level manipulation of values, but disagreed about gluing good old-fashioned AI, such as rules and logic, to neural networks. I will come back to these AI research paths later in this chapter. Jeff Hinton reasons that the future of human-level AI will likely be different to what people think, as individual AIs would not necessarily get uniformly better and more intelligent on all fronts, and that we will likely see networks or communities of intelligent systems where individual AI systems interact with one another, sharing data, training outputs, and information. In his interview with Martin Ford, he specifically mentions that he thinks that general reasoning capacity will take a long time to be developed, anything from 10 to 100 years. Jeff also thinks that global nuclear war or biological warfare with, for example, a very contagious and lethal virus with a long incubation time are much more dangerous existential threats compared to very intelligent AI systems. That said, he is still concerned about lethal autonomous weapons and suggests that it should be handled in a similar way as chemical warfare and weapons of mass destruction is treated by the international community. Due to substantial private, public, and academic resources and talent being put into AI, Stuart Russell expects a higher rate of breakthroughs and human-level AI to happen within his children's lifetime and not hundreds of years in the future. However, there are many key problems to solve on our way to strong AI, such as how natural language can produce knowledge structures and understanding upon which reasoning processes can operate, operating over multiple scales of abstraction, and developing their own behavioral hierarchies that allow the AI systems to operate successfully in complex environments over long timescales. In addressing Martin Ford's question about how things would unfold when the first human-level AIs appear, Stuart thinks that this is going to happen along many dimensions, at different skills and knowledge levels, and would have different abilities and strengths to that of humans. Stuart is also advocating for developing AI systems that focus on achieving our goals as opposed to their goals, without necessarily knowing our exact goals. He explains that having an explicit uncertainty about the nature of goals that the AI systems are instructed to pursue leads to a margin of safety that we need in building safe, controllable, and trustworthy AI systems. In Stuart's essay, The Purpose Put into the Machine, he highlights some key aspects of this approach towards provable beneficial AI, where a formal problem to be solved by an AI system can, for example, be to maximize human future life preferences subject to their initial uncertainty about them, where the AI system keeps learning about them but never able to achieve complete certainty. This approach fits in with the research priorities for safe and trustworthy AI. Stuart Russell also has a chapter in his book Human Compatible Artificial Intelligence and the Problem of Control that is called The Not So Great AI Debate, where he addresses so-called AI denialist arguments to not look seriously at poorly designed superintelligent AI systems that could present an existential risk to humanity. He refutes the denial type of arguments that has the form of "it's complicated, it's impossible, it's too soon to worry about it, and we're the experts," with arguments such as strong AI that exceeds human capabilities in all relevant dimensions of intelligence would give them power over us. Intelligence is not the same as arithmetic or physical strength. There is also the first time for everything. We cannot insure against a superintelligence simply by betting against human ingenuity. Very rapid progress in AI research puts us on a path of having strong AI that can lead to us losing control. A long-term risk can still be cause of immediate concern. For example, large asteroid on course to collide with Earth. This type of AI risk was identified by many experts in the field since its inception, and AI denialists are exhibiting tribalism in defense of technological progress. One example he uses is Leo Szilard's invention of a nuclear chain reaction mediated by neutrons a day after Ernest Rutherford claimed it was not possible in 1933. The second type of argument is a deflection that has the form of "you can't control research, but what about?" or just silence about the risks since they cannot be addressed, or there are more immediate problems to solve than a potential existential threat. Stuart uses the example of nuclear physics research not being banned just because of containment failure risks in nuclear plants, as research also focuses on solving the containment problem. We also have a current example where human germline engineering, the process by which the genome of a human is edited in such a way that the change is heritable, has been prohibited by law in many countries, along with broad agreement among the scientific community to not pursue the research in this area for ethical, safety, and social reasons. Stuart also states that if the risks are not properly addressed, this might lead to a situation where we see no AI benefits. He references how the growth in the nuclear industry has been severely impacted by 3 nuclear disasters at 3 Mile Island in 1979, Chernobyl in 1986, and Fukushima in 2011. The third type of argument has the shape of a quick oversimplified solution and use words like "we can just switch it off," or "put it in a box," or alternatively work in human-machine teams, avoid putting in human goals, or even merge with the machines. He argues that a superintelligent AI system would already know about the possibility of it being switched off and will ensure that this would not happen. The same holds for a superintelligent AI system in a box, where we do not even have a firewall that is secure against humans. Whereas Elon Musk's Neuralink sees merging with the machines as a potential defending strategy, others like Ray Kurzweil see such a scenario in favorable light. Even if the strong AI system doesn't have human goals, it would still have desires that are built into its objectives or sub-goals to, for example, avoid actions that would prevent it from achieving its objectives. As having intelligence implies having objectives, a superintelligent AI system will also have objectives of some sort. As also noted by Nick Bostrom, intelligence and objectives are independent from one another, as the superintelligent AI system would use its intelligence to pursue its objectives, accepting any reward signal. Orion Etzioni, the CEO of Allen Institute of AI, and his team are amongst other working on Project Mosaic, which focuses on building common sense in an AI system, which is one of the key features of human-level intelligence. In his discussion with Martin Ford, Orion mentions that we are very far from achieving strong AI and sees some of the building blocks towards human-level intelligence as the ability for an AI system to do multiple tasks that are dissimilar to each other, to be very data efficient, have the ability to self-replicate, and apply its knowledge and capabilities in a different domain not being trained on. He also reckons that some of the greatest AI benefits include its use in advancing science to help improve medicine and solving problems in healthcare, and also to reduce accidents through the use of self-driving cars. Some of the major short-term risks include the impact on the job market, cybersecurity, and lethal autonomous weapons. Orion also states that with their work on natural language understanding, they are also participating in AI safety research to complement any research being done with the value alignment problem. He also thinks that there is a major distinction between intelligence and autonomy, and that one can have high intelligence without any autonomy, as well as the reverse. Autonomy is potentially more dangerous than intelligence, as we can see with computer viruses or lethal autonomous weapons. As a psychology and neuroscience researcher at New York University, Gary Marcus does not think that developing human-level intelligence requires replicating exactly the way the human brain works. In a recent book called Rebooting AI, Building Artificial Intelligence We Can Trust, which Gary co-authored with Ernest Davis, they discuss the limitations of deep learning, which is good at perceptual pattern classification using bottom-up information, but not good at common sense reasoning, for which symbol manipulation via mathematics or language processing might be a more suitable solution as part of a trustworthy AI system that has common sense values and reasoning built in. Gary also regards the work that the Allen Institute of AI is doing with regards to embedding human knowledge in computable form via Project Mosaic as an important step towards strong AI. When asked about a time frame for strong AI, he thinks that it is achievable and provided a confidence interval of 2030 to 2130, with a likely date of around 2050. For self-driving cars to become fully operational on our roads, he also predicts a 2030 or beyond time frame. Although Gary does not completely discount it, he is like many other AI researchers not concerned at this point with recursive, self-improving superintelligent AI systems that will pose an existential risk to humanity, as he does not see definitive evidence that AI research is going in that direction. He is much more concerned with humans using AI for malicious purposes, bioterrorism, cyber warfare, cybersecurity threats in the short term, misinformation, and AI not optimally being used and distributed for the benefit of humanity. Demis Hassibis, AI researcher and CEO of DeepMind, has made it clear since the inception of DeepMind that their development of neuroscience-inspired AI systems is driven by the mission to solve intelligence and advance scientific discovery for all. Although they have been acquired by Google a few years ago, they are still focused on this goal with an excellent track record of breakthroughs by demonstrating human-level and beyond capabilities in playing board games such as Go, chess, and Shogi, with AlphaGo, learning Go from human and computer play, AlphaGo Zero, self-taught without learning from human Go games, Alpha Zero, generalized to play Go, chess and Shogi, and Mu Zero, learns without being taught the rules. In a more recent breakthrough, DeepMind was able to effectively solve the protein folding problem, which is one of biology's imposing challenges. This was accomplished through the latest version of AlphaFold that predicts 3D models of protein structures from its amino acid sequence significantly more accurately than traditional computational methods, which amongst other things enables quicker and more advanced drug discovery and a better understanding of the building blocks of cells, as well as the causes of diseases that are the result of misfolded proteins. In discussing the key obstacles to address in achieving human-level AI, Demis specifically mentions transfer learning that allows an AI system to transfer knowledge from one domain to a new domain, language understanding, and symbolic manipulation using DeepMind's techniques. When Martin Ford asked Demis about the existential alarmist views of Nick Bostrom and Elon Musk, he responded that it might sound radical, but that it is a lot more nuanced when you talk to them in person, and that he has a more moderate view on this. He thinks AI is going to be the most beneficial technology that humanity has ever created, but to live up to this promise, we have to make wise decisions in how we design, apply, and allocate the benefits to society. Although Demis agrees that recent breakthroughs have made it necessary to start doing research on the control and value alignment problems, he reckons that the AI technology is still at an emergent stage and that we will be able to understand and reverse engineer these intelligent systems to manage the technical risks. Demis is also concerned about lethal autonomous weapons and supports the Future of Life's perspective on this. He also feels that there is a good collaboration within the international AI research community, but that we need to work on better international coordination as well as relevant regulations and standards for AI applications. Although AI can be used to help solve a lot of the world's problems, we need to create an economy where the productivity gains generated by AI's transformation are shared with everyone. Andrew Ng, an adjunct professor of computer science at Stanford and previously chief scientist at Baidu, as well as a co-founder of the Google Brain Project, Coursera, an online education company, Landing AI, and a venture capital company, AI Fund, that builds AI startups, thinks the path to strong AI is unclear and likely not possible in his lifetime. Although we have made excellent progress with narrow AI through deep learning, and will unlock significant further value across multiple industries, he does not think we can make simple extrapolations to strong AI and feels that this has created unnecessary hype. Although Andrew thinks that we now have enough deep learning research and application momentum to ensure that we should not go into another AI winter, he thinks we should reset expectations with respect to strong AI. Apart from some of the current limitations or areas of improvement of deep learning, such as causality, explainability, adversarial attacks, learning from small datasets, get better at transfer and multitask learning, and the need to use unlabeled data better, he highlights unsupervised learning that mirrors the way that children learn to be one of the key building blocks for achieving strong AI, and sees neural network type of approaches to continue play a key role in getting there. Daphne Koller, a professor of computer science at Stanford and co-founder of Coursera with Andrew, as well as CEO and founder of biotech startup In Situ, thinks that although deep learning has been a tremendous success so far, we need at least one breakthrough, but likely a few more, before we get to strong AI. She reckons that these breakthroughs are unpredictable stochastic events that can take 1 month or 150 years, and even when it happens, it would require a lot of engineering, like we have seen with deep learning and its foundations that effectively evolved over decades. Daphne's opinion is that as strong AI has not even been invented, we are far removed from any possible AI-induced existential risks, and when breakthroughs occur, we will be in a better position to understand the key components so as to engineer safe and trustworthy strong AI. Although she is not in favor of governments regulating things that they do not understand, which currently in general looks to be the case with respect to AI technology, She makes the point that many of the short-term risks associated with the smart technology era, such as privacy, security, bias, lethal autonomous weapons, are already here and should be addressed as a matter of priority. Some key limitations of current AI include the inability to transfer knowledge and skills from one domain to another by being restricted to end-to-end training within single architectures that can only achieve narrow vertical tasks, as well as the dependence on significant amounts of data to train these focus models. Andrew and Daphne's colleague Fifi Lee, a professor of computer science at Stanford and chief scientist of Google Cloud, see narrow and strong AI all on the same continuum, where human-level AI systems have multiple dimensions, are situationally aware, understands context, and mirrors human learning that includes unsupervised learning, reinforcement learning, and virtual learning. She's a big proponent of democratizing AI and human-centered AI that enhances and augments humans within a job market context, follows a collaborative interdisciplinary research approach that includes neuroscience, behavior science, and cognitive science, and also involves multiple stakeholders to help unlock opportunities and address issues with respect to the economy, job market, regulations, policies, ethics, diversity, bias, security, and privacy. Fifi's Google colleague Jeff Dean, who is the director for AI and head of Google Brain, envisages the path to human-level AI as building single systems that have the capability to perform many different tasks and progressively using the knowledge from solving these tasks to tackle new problems, along with the supporting large-scale computational infrastructure and hardware required to do so. Jeff is also not that concerned about Nick Bostrom's superintelligence existential risk and believes that we need to apply wisdom to make good choices in the way we develop, integrate, and use AI in society to the benefit of humankind. In Nick Bostrom's interview with Martin Ford, he mentions that it is still too early to have governments getting involved with strong AI concerns, as it is not clear what should currently be done, unlike specific narrow applications that can be regulated, such as lethal autonomous weapons. Although Nick agrees that current alarmist remarks about strong AI being a greater existential threat than, for example, nuclear war or, say, North Korea, is premature and could potentially make things worse, there are still a lot of foundational work on value alignment, the control problem, safety, and governance that needs to be done in collaboration with the AI research community, such as those via the likes of the Future of Humanity Institute, FHI, at Oxford University, DeepMind, OpenAI, the Machine Intelligence Research Institute at Berkeley, and others. According to him, humanity needs more wisdom on what we focus on and how we allocate our time and resources. For example, Nick's team at FHI are focused on macro strategies for existential risks that relates to strong AI and biosecurity and does not regard climate change as an existential risk, although the latter is an important problem to address. Joshua Bach, cognitive scientist and VP research at AI Foundation, thinks that even though nobody seems to know how to truly build strong AI yet, and current narrow AI systems are not likely to scale to strong AI, we should still be concerned about it, as many, although not all, of the significant open questions in developing strong AI appear to be known and solvable, and there is no apparent reason why the implementation of the principles embedded in biological brains should not be within our engineering reach. Strong AI will not have the limitations of biological brains that are maximizing their evolutionary fitness or future options, and will scale better to achieve its goals, which in the wider sense might be to consume the maximum negative entropy that can be scraped from the universe over time. Our human reward functions are much more constrained and need to incorporate physiological, social, and cognitive demands, as well as consider human values such as reducing suffering, improving the content of mental representations, preserving human civilization, and preserving life. He conjectures that whereas the existing narrow AI is probably sufficient for ending our labor-based economy sometime in the future, strong AI may pose an existential risk as one of many other ones where the ultimate existential risk is running out of negative entropy. Joshua believes that investing in AI safety is warranted and that strong AI may also help us in preventing some other existential risks. He also references Lebowski's theorem that states that no superintelligent system is going to do anything that is harder than hacking its reward system, and asks if we can build a machine that is completely truthful. Judea Pearl, a professor of computer science and statistics at University of California and author of books such as Heuristics, Probability Reasoning Causality, and the Book of Why, believes that data-driven machine learning approaches, such as deep learning, is limited in that it just learns from data and cannot understand cause and effect, interpret counterfactuals, or operate on an imaginary level, which allows the building of new models of the world. Judea does not think there are any theoretical hindrances towards developing human-level AI and sees both deep learning and causal reasoning as part of the building blocks to achieve this. In his essay, The Limitations of Opaque Learning Machines, Judea views machine learning as a tool to go from data to probabilities and then to go from probabilities to true understanding, which involves predicting the effects of the actions and then imagining counterfactuals. He also highlights a causal reasoning theoretical framework where on the first level of the three-level hierarchy, statistical reasoning is used to update the beliefs about events. A second level is dealing with actions that requires information encoded in a probabilistic graphical model about interventions not available on the first level, and the third level is dealing with counterfactuals. He specifically mentions to Martin Ford that we should be wary of strong AI, as it can effectively lead to breeding a new species of intelligent animals that can have an inner experience and emotions and assume their own agency. Rana Al-Kaloubi, the CEO of Effectiva, which is a company that spun out of MIT labs and focuses on building AI solutions that sense and understand human emotions, strongly believes that we should design and deploy these AI systems in ways that do not remove our agency as humans. She also thinks that we are very far away from building systems that have human-level artificial general intelligence and do not subscribe to fears about AI being an existential threat to humanity. She is more concerned about us preserving the existing biases that we currently have in society by not being diligent about the data we train our AI systems on. Rana is a proponent of regulating specific AI applications and also has Effectiva publishing best practices and guidelines, especially on ethics and privacy as it pertains to emotion-related AI solutions. Daniela Russ, the Director of Computer Science and AI at MIT, also thinks that human-level AI is not likely to be achieved in the near future, and thinks that the founders and thought leaders in the AI field from 60 years ago would actually be disappointed in the progress made so far. In her mind, we need exceptional breakthroughs to bridge the gaps in our understanding of human intelligence, along with how the brain accomplishes this, and that significant progress will likely be as a result of interdisciplinary and multidisciplinary research that involves at least fields such as computer science, neuroscience, and cognitive science. Cynthia Brazil, a director of the Personal Robotics Group at the MIT lab and founder of Jibo that provides social robots for the home, is also less worried about strong AI risks compared to the risks associated with people that can misuse AI to do harm or negatively impact our privacy and security, or manipulate people through fake information or develop lethal autonomous weapons. She is a champion for developing complementary human-machine social interactions, building machines that support our ethical and human values, driving an AI-literate society, and democratizing AI for all to benefit. Cynthia also questions the practical driving forces to create human-level AI from a long-term commitment, funding, resources, time, patience, and talent perspective, and thinks that our current efforts might just lead to broader and more flexible versions of the current narrow AI applications. There are many things that our current narrow AI systems cannot do, such as doing multiple tasks, real-time ongoing learning as a child, learn from a few examples and generalize, human-level common sense, deep emotional intelligence, and a deep theory of mind. Josh Tenenbaum, a professor of computational cognitive science at MIT, is focused on reverse engineering the human mind through understanding human intelligence from a computational perspective and developing these learning and reasoning capabilities in machines to achieve human-level intelligence. In developing strong AI systems, he disagrees with the approach to learn everything from scratch, as is for example done with DeepMind's AlphaZero, but instead have a high-level roadmap that first focus on the pre-linguistic intelligence of the first year and a half of a human baby's life that is more geared towards intuitive physics and concepts of the real world, intuitive psychology, and the understanding of other humans' actions. This is followed by building language that is typically exhibited from 1.5 to 3-year-olds, and finally from 3 years and up, using language to build and learn everything else required to operate efficiently and effectively in the real world. Although there is a general acknowledgement that deep learning is a key component in the AI toolbox for especially pattern recognition tasks, symbolic AI as well as graphical models and Bayesian networks are other key tools that have, according to Josh, an important role in creating hybrid AI systems that can be used to capture people's mental models of the world. These probabilistic programming systems can be integrated with deep learning types of models to speed up inference in the hybrid AI systems, in a similar way that deep learning is also speeding up inference and search in an AlphaGo game tree. With these hybrid AI systems, it is possible to also capture genetic and cultural information and structures and effectively search in a space of genetic or cognitive thinking types of programs. Josh argues that a deep reinforcement learning type of blank slate approach, which just focuses on modeling evolutionary human intelligence over many generations and not what a baby does, is limiting and does not capture how biology works over evolution or the lifetime of a person. Also, in order to build human-level AI, we would likely need to build in a kind of unitary experience of the world and not at the level of neurons firing. This would give these systems the ability to think, learn, or make decisions for itself. Josh is also not currently concerned with potential risks around strong AI, as we are very far from building such systems, and we have more pressing short-term concerns that need our full attention, such as using technology for selfish or evil purposes, stress on the workforce with jobs disappearing within generations, privacy, human rights, and surveillance. David Ferrucci, CEO and Chief Scientist at Elemental Cognition, in partnership with Bridgewater Associates, and previous head of IBM Watson, states that their goal is to produce AI systems that can process language similar to how humans do it, learn through language, and deliver knowledge effortlessly through language and reason. He thinks that human-level intelligence has 3 parts, which include perception, control, and knowing. Whereas deep learning and neural networks-based techniques deal very effectively with perception and control, their team is focused on knowing and understanding by developing human-compatible intelligence that is anchored in language, logic, and reason. Elemental cognition makes use of neural networks, formal reasoning, formal logic representations, unsupervised learning from large corpora, and continuous dialogue with people and other sources of incremental knowledge. David reckons that they are making enough progress with this type of approach to autonomous language understanding that human-level AI is possible within approximately 10 years and not a 50 or 100-year wait. He is also less worried about the existential risks of superintelligence, as we would need to give AI systems the ability to develop its own goals, desires, and plans to do harmful things and have leverage over us and our systems. It is much more important to ensure that we do not give AI systems leverage over systems that, for example, control our national security, transportation, electric grids, and food supply chain. James Manyika, a senior partner at McKinsey & Company and chairman of McKinsey Global Institute, has a balanced perspective on existential risks with respect to superintelligent AI with recursive improvement. Even though the probability of the latter is very low, and we are very far away from strong AI, He thinks that it is good that we have small groups of researchers thinking about these potential value alignment and control problems, but should not involve governments or incite society about this at this point. Like many others, David has the opinion that AI regulation should focus on aspects such as safety, privacy, transparency, and democratizing AI. Brian Johnson, the founder of Kernel, OS Fund and Braintree, believes that the future of Homo sapiens will be defined by the combination of AI and human intelligence. He thinks that AI is the best thing since sliced bread and a wonderful tool to accelerate radical human enhancement. Although he is respectful towards Nick Bostrom's work on the potential control problem that relates to a runaway strong AI, he regards the alarmist existential threats about strong AI by some influential business people and scientists as unfortunate and unnecessary scaremongering of society. Brian reckons that it is foolish to say that AI is humanity's biggest threat and regards ourselves to be our own biggest threat, as clearly demonstrated throughout history. We can use smart technology to do fantastic things, but also create enormous harm. Barbara Grosch, a professor of natural sciences in the School of Engineering and Applied Sciences at Harvard University, is not convinced that we should pursue strong AI with its potential ethical hazardous outcomes and see it as a distraction to the short-term risks and ethical issues that we face with our current applications of AI and technology in the broader sense. She has also experienced a number of AI winters and thinks we should manage expectations of AI better by, for example, making clear what the current strengths and limitations are of deep learning and other techniques in the AI toolbox. In a discussion with Martin Ford, she said that AI systems are best if they are designed with people in mind. Barbara thinks that AI research and applications in healthcare and education that complement people are some of the best use cases that we should focus on. OpenAI, an AI research laboratory that consists of the non-profit OpenAI Inc. and its for-profit subsidiary corporation, OpenAI LP, is another company such as Google DeepMind that has a stated goal of developing strong AI. Under the leadership of Sam Altman, CEO, Greg Brockman, CTO, and Ilya Sutskever, Chief Scientist, they are specifically focused on developing safe and beneficial artificial general intelligence that benefits all of humanity, even if they help others to also achieve this outcome. Ilya Sutskever is of the opinion that strong AI is a serious possibility over the short term, whereas Greg Brockman said that huge computing power is a key driver to reach human-level AI. OpenAI has initially received $1 billion investment from high-profile contributors such as Elon Musk, Sam Altman, Peter Thiel, Reid Hoffman, and Jessica Livingston, followed by another $1 billion from Microsoft in 2019 to speed up its pursuit with required computational infrastructure. Over the next few years, OpenAI intends to build an AI system that can run a human brain-sized AI model, but also mentions that some algorithmic advances will be required to make use of the huge increase in computing power. One of the product lines delivered over the last few years include the generative pre-trained transformer language prediction models GPT, GP2, and GP3, where the latest version has a capacity of 175 billion parameters with excellent performance on many natural language processing datasets, including question answering, translation, and closed tasks, i.e. fill in the blanks, as well as a number of tasks that require prompt reasoning or domain adaptation, such as using a new word in a sentence, unscrambling words, or performing 3-digit arithmetic. Similar to DeepMind, OpenAI's research is making heavy use of deep reinforcement learning and has also video game applications such as OpenAI 5 OpenAI curated bots, playing in a competitive 5-on-5 video game Dota 2, where the latest version in 2019 has defeated a world champion human team 2-0, as well as obtained a winning percentage of 99.4% of its games in a 4-day open online competition. As can be seen above, many AI researchers do not believe that AI approaches that mainly incorporate deep learning, which is more focused on pattern recognition, will be able to reach human-level intelligence. Oren Etzioni has, for example, said that to reach the next level of AI, we need some breakthroughs. I'm not sure it's simply throwing more money at the problem. As also mentioned above, Gary Marcus believes that deep learning should be viewed not as a universal solvent, but simply as one tool among many. Stuart Russell said that focusing on raw computing power misses the point entirely. We don't know how to make a machine really intelligent, even if it were the size of the universe. Greg Brockman's response to this criticism is that one can get qualitatively different outcomes with increased computation, and references the significant improvements with its generative GPT type of language prediction models that is developing an increasing degree of semantic understanding, as well as OpenAI 5 that demonstrates some planning by teaching itself to operate at a higher level of abstraction, setting a high-level goal, and then focusing on particular tasks as needed. As visually illustrated by Ilya Sutskever in his 2018 talk showing the compute power for different AI models from 2009 to 2018, there has been a 300,000x increase in compute from AlexNet to AlphaGo Zero. Greg Brockman mentioned that the past 7 years of advances would be like extending the battery life of a smartphone from 1 day to 800 years. Another 5 years on the same exponential curve would take that to 100 million years. In John Brockman's Possible Minds, 25 Ways of Looking at AI, he and other authors debate the future of AI as they reference Norbert Wiener's The Human Use of Human Beings in 1950, which appears to be as relevant as ever in 2020 and beyond, as he conveys his worry at that time about the uncontrolled commercial exploitation and other unexpected consequences of advanced technologies. At the time of Norbert Wiener, the advanced technologies of control and communications that he referenced were called cybernetics, which comes from the Greek word that means governance, and is the concept of automatic self-regulating control. Although AI was missing from Wiener's vision, the underlying message is still applicable today with our narrow AI applications and as we develop more capable machine intelligence that might eventually lead to strong AI with unsupervised and self-improving capabilities. Seth Lloyd, a theoretical physicist at MIT, echoes Wiener's sentiments in his essay, Wrong but More Relevant Than Ever, and also points out that whilst information being a key component in governing the behavior of complex systems was correctly highlighted, the potential of digital computation was unrecognized at that time. He also thinks that similar to 70 years ago, that technology overestimation is also happening today, and that despite excellent progress in AI, the expectations around deep learning should be tempered. In the essay The Inhuman Mess Our Machines Have Gotten Us Into, Rodney Brooks strongly feels that humankind has gotten itself into a conundrum with people being exploited by companies that provide services that they desire, as well as some governments that manipulate people or smothering opposition. He feels that our current predicament is actually more complex and worse than what Norbert Wiener has envisioned. George Dyson, a historian of science and technology, conjectures in his essay, The Third Law, that provable AI is a myth and it is possible to develop something without having an understanding how it works. He bases this on a loophole in what he calls the third law of AI, that states that any system simple enough to be understandable will not be complicated enough to behave intelligently, while any system complicated enough to behave intelligently will be too complicated to understand. George further has a controversial opinion that the next computing revolution will be analog systems over which digital software development has no command, and that we should be more concerned with self-reproduction, communication, and control. Daniel C. Dennett, a professor of philosophy at Tufts University and author of a number of books such as Consciousness Explained, advocates in his essay, What Can We Do?, that we need intelligent tools that can solve problems and not artificial conscious agents that can have rights, feelings, be able to respond with discontent, or even potentially able to enslave us. Daniel would like to see that we develop Oracle-type AIs with no conscience, personality, fear of death, or distractions due to their own preferences. Max Techmark in Let's Aspire to More Than Making Ourselves Obsolete, is of the opinion that extinction is a possibility if our smart technology develops faster than the wisdom that we need to manage it responsibly, and would be very unfortunate given that the potential upside and opportunities that AI presents are tremendous and might enable life in various forms to thrive for millions or even billions of years throughout the universe. Jan Tallinn, a computer programmer and co-developer of Skype and investor, has been laser-focused on driving the AI risk message through his involvement with and support for the Future of Life Institute, the Machine Intelligence Research Institute, and others working on AI safety and risk reduction. The initial impetus was provided by Eliezer Yudkowsky's revolutionary message: continued progress in AI can precipitate a change of cosmic proportions, a runaway process that will likely kill everyone. We need to put in a lot of extra effort to avoid that outcome. In Dissident Messages, Jan states that the initial AI risk message to the public had a huge flaw in that it does not communicate the true scale of the problem or AI's potential benefits. On the risk side, he thinks that super intelligent AI is also an environmental risk, as it could potentially lead to Earth being turned into an uninhabitable environment for biological life forms. On the upside, we can create a future in which all people's lives are massively improved and potentially expand life well beyond Earth and the solar system. Steven Pinker, a professor of psychology at Harvard University and author of a number of books including Enlightenment Now, The Case for Reason, Science, Humanism, and Progress, has an opposing view and states that the two moral themes of Norbert Wiener's The Human Use of Human Beings, of a dystopian fear of a runaway technology and the liberal defense of an open free society, are in conflict with one another. In Tech Prophecy and the Underappreciated Causal Power of Ideas, Stephen articulates several misconceptions about a sudden AI takeover where intelligence are confused with motivation. Be intelligent is not the same as wanting something. Intelligence are seen as a limitless continuum of power to reach any goals or solve any problem. No law of complex systems states that intelligent systems will become cruel, self-absorbed entities, and leaning too much on the steep upward curve of the current AI hype cycle. According to him, the runaway superintelligence scenarios with the value alignment problem are also contradicting, as it depends on the assumption that humans are so smart that they can build a superintelligent system but so stupid to give it full control without testing it, or that the AI system is so intelligent to solve many impossible problems but so foolish to create chaos due to some misunderstanding about conflicting goals, which should actually be handled by the AI's intelligence. David Deutsch, quantum physicist at Oxford University and author of The Fabric of Reality and the Beginning of Infinity, states in his essay Beyond Reward and Punishment that human-level intelligence is about thinking, which he describes as the process of creating understanding or explanatory knowledge. He reckons that this is a property that strong AI should aim for. David is specifically arguing that misunderstandings about human thinking and how we developed also causes similar misunderstandings about strong AI and how to develop it. Given hundreds of thousands of years where thinking was not really used for innovation but mainly for imitating new complex behavior, and progress occurred on longer timescales than a typical human lifetime, the benefits of humans' innovation capability did not contribute to the biological evolution of the human brain, as it was primarily driven by the benefits of preserving cultural knowledge. Before the period of enlightenment, the culture of rewards and punishment enforced on humans over centuries created an environment of compliance and stagnation that did not encourage innovation, technological breakthroughs, or creative thoughts towards improvement or transformations. As in the current era with humans, we should go beyond reward and punishment in developing strong AI and give them the ability to search for a better goal under unknown constraints. Instead of creating a totally obedient moron type of AI, as all other software or narrow AI systems that does not know what it is doing or why, we should aim for the opposite, a so-called disobedient autonomous thinking application that is more similar to raising a child. David thinks that a strong AI system should not be restricted by fixed testable criteria to determine if the output generated is correct or controlled by a flow of externally enforced rewards and punishments that would be detrimental to the system's ability to develop creative thought, as in the case of humans. He therefore reckons that any testing in the process of developing a strong AI will be counterproductive and immoral, as it is with humans. As a strong AI should be free to choose its own ideas, objectives, methods, and criteria, we would only see its abilities to search for explanatory knowledge when the system is executing. David agrees that such strong AI systems could be dangerous in a similar way as their human counterparts and should operate as members of an open, stable kind of society with similar rights and cultural membership as humans, where everyone chooses their own internal and external rewards. In terms of fears that strong AI can behave in an erratic or dangerous fashion that deviates away from the culture's moral values, David conjectures that all current existential risks that stems from a growth in explainable knowledge comes from weapons of mass destruction in the hands of mentally twisted agents, humans or AI systems, that are the enemies of civilization and not rebellious youths. He also sees the belief that strong AI are uniquely threatening due to them executing on ever-improving hardware as a misconception, as human thought will also be boosted by the same technology. He argues that human brains should be able to think anything that strong AI can think or compute, depending on only the speed or memory capacity of these strong AI systems, and that the latter can also be made equal by empowering humans with the same technology. Tom Griffiths, a professor of information technology, consciousness and culture at Princeton University and co-author of Algorithms to Live By, advocates in his essay The Artificial Use of Human Beings that strong AI systems should develop good generative cognitive models of human behavior to better understand, make conjectures about human desires, and respond to human needs. Tom sees this as a prerequisite for solving the value alignment problem. His research group is focused on developing a more realistic model of rational behavior that incorporates computational constraints to find the right algorithm that creates a balance between thinking too much and making errors. This trade-off is called bounded optimality as a theory of human behavior where a rational model bridges the gap between rationality and heuristics and functions as a key component to make AI systems more intelligent in interpreting people's behavior. Anke Dragan, an assistant professor of electrical engineering and computer science at UC Berkeley and research collaborator of Stuart Russell, also shares Stewart's engrossment with AI safety in her essay, Putting the Human into the AI Equation. She is arguing for human-compatible AI that addresses both a coordination problem, where AI systems recognize and treat people as more than just objects in the environment and able to reason about and interact with them in optimal fashion, as well as a value alignment problem where people determine the reward function of the AI system to ensure that it is in line with what society, the consumer, or the developer wants. Chris Anderson, CEO of 3DR, former editor-in-chief of Wired and author of The Long Tail, Free and Makers. In his essay, Gradient Descent, he uses gradient descent, which is a first-order iterative optimization algorithm for finding a local minimum of a differentiable function and also used to train AI systems, as a metaphor to illustrate the path that life, humans, and AI systems are following to improve and get to better solutions and systems, including an AI system that will one day be as smart as a mosquito and beyond. David Kaiser, a professor of the history of science as well as of physics at MIT, in Information for Wiener, for Shannon, and for us, imagines a scenario where AI systems might be used to develop meaningful information rather than a persistent quest of less meaningful activities that also concerned Norbert Wiener, such as the rampant militarism, runaway corporate profit-seeking, the self-limiting features of secrecy, and the reduction of human expression to interchangeable commodities. Neil Gershenfeld, a physicist and director of MIT's Center for Bits and Atoms, in his essay, Scaling, predicts that the same scaling trends that made the current success of AI possible will be followed by the merging of AI and natural intelligence, where atoms arranging bits, arranging atoms, and the paths of AI and machine making becomes intertwined. In his essay, The First Machine Intelligences, W. Daniel Hillis, a professor of engineering and medicine at USC and the author of The Patterns on the Stone, The Simple Ideas That Make Computers Work, outlines 4 possible scenarios for how strong AI will relate to our existing hybrid superintelligence systems, such as countries and multinational corporations, which have their own emergent goals and their actions that are not always aligned to the interests of the people who created them. These include multiple strong AI systems being controlled by individual countries or regions, AI systems being controlled by multinational for-profit corporations that can even become more high-powered and autonomous than individual countries, strong AI systems that pursue their own goals and are not aligned with people or hybrid superintelligences, or strong AI systems that pursues humanity's goals, restores the balance between individuals, corporations, and states by empowering the people with AI capability. The latter is clearly the preferable one. As Daniel says, the future is not something that will happen to us, it is something that we will build. Venki Ramakrishnan, a molecular biology scientist at Cambridge University, Nobel Prize winner in chemistry and author of Gene Machine, The Race to Discover the Secrets of Ribosome, provides some important perspectives in will computers become our overlords, such as that even though in the bigger scheme of things, human intelligence is just another survival mechanism, we still define our very existence and why we are special by this attribute. Even our fears about strong AI are reflected by this belief. Just to give further perspective in terms of resilient species on Earth, he feels confident that strong AI will never have mastery of bacteria. Alex Sandy Pentland, a professor of media arts and sciences at MIT and author of Social Physics, in his essay The Human Strategy, emphasizes that the common sense understanding that humans within a networked society brings to solving problems, along with the ability to dynamically shape its social networks, can be used to good effect in creating a human AI ecosystem and culture that has a human feel to it. Hans Ulrich Obrist, artistic director of the Serpentine Gallery in London and author of Ways of Curating and Lives of the Artist, Lives of the Architects, in his essay Making the Invisible Visible, Art Meets AI, would like to see a world where AI is used as a tool for creativity and not replacing artists, where we have closer collaboration between engineers and artists, and where we create a space that is non-deterministic and non-utilitarian in its plurality of perspectives and diversity of understandings. Caroline A. Jones, a professor of art history at MIT and author of Eyesight Alone, provides an arts history perspective in her essay, The Artistic Use of Cybernetic Beings, against the backdrop of her goal to develop a new cultural evolution paradigm aimed at communalism and interspecies symbiosis rather than survival of the fittest. Alison Gopnik, a developmental psychologist at UC Berkeley and author of books that include The Philosophical Baby, mentions in AIs versus 4-year-olds that we can improve the machine learning capability of AI systems by incorporating features of children's learning, such as active curiosity-driven learning, as well as social and cultural learning. Although we need to regulate certain AI applications, she thinks that human stupidity can be far more damaging than AI systems. Also, current AI systems can easily be outperformed by the average 4-year-old child. In Algorithms' Dream of Objectivity, Peter Gallison, a science historian and professor at Harvard University and author of Einstein's Clocks, Poincare's Maps, Empires of Time, mentions that as the legal, ethical, formal, and economic spheres of life are becoming more governed by algorithms, it is important to take into consideration that AI-driven predictive analytics based on mechanical objectivity sometimes comes at a price that is worth paying and sometimes detrimental to a just society that we aspire to. Judgment is sometimes still needed to make that call. In the essay, The Rights of Machines, George M. Church, a professor of genetics at Harvard Medical School and co-author of Regenesis, How Synthetic Biology Will Reinvent Nature and Ourselves, has a more positive perspective on the future of strong AI, but is still worried about teaching these systems ethical behavior, especially given our track record in teaching ourselves ethical behavior and giving them proper rights. George also thinks that we already have people that are transhuman if defined as people and cultures not comprehensible to human living in modern yet technological culture, and ask what are their rights. In Artificial Intelligence and the Future of Civilization, Stephen Wolfram, scientist, CEO of Wolfram Research, and author of A New Kind of Science, sees technology as taking human goals and making them automatically executable by machines. He thinks that goals and purposes are uniquely human and defined by personal history, biology, psychology, cultural environment, and the history of our civilization. Human goals have significantly varied over time and are typically linked to some sort of scarcity to a large extent. As time is also a scarcity, Stephen reckons that the most considerable discontinuity will likely be when humanity gets to effective biological or digital immortality. As he does not think that inventing goals has a path to automation, we need to equip AI systems with goals. In order for AI systems to execute our goals, we need to engage with them via language that could be understood by AI systems and humans. As natural language has not worked so well thus far, Stephen and his Wolfram Alpha team has developed a knowledge-based language that incorporates the knowledge of the world in the form of science and data collection directly into the language and aims to convert human thought into a form that a computer can understand. Although it can represent objective knowledge of the world, the problem is to represent everyday human conversation in accurate symbolic way. We also need to take in consideration that the communication channel between AI systems and humans are evolving into a visual, higher bandwidth one compared to just a Turing test type of language communication. Stephen identifies 4 levels of how knowledge has been transmitted in the world's history, which starts with genetics, then a physiological recognition of various kinds of objects and the learning of knowledge, followed by natural language that allows knowledge to be represented sufficiently abstract for brains to interact with one another, and finally, knowledge-based programming that creates an actual representation of real things in the world in an accurate symbolic fashion. Besides that, the knowledge-based code can be understood by both humans and AI systems. Another key feature is that the code is executable by computers. Stephen would like to see people learn to think computationally and ask what the world would look like if most people can code. He sees coding as a form of expression. In a similar way, writing in a natural language is a form of expression, but with the added advantage that it is instantly executable as computations. Stephen also thinks that there is an equivalence between the kinds of computations that different complex systems are doing, such as brains, living cells, the weather, and the Earth's global climate. As there does not seem to be a clear-cut distinction between intelligence and computation, it is difficult to claim that humanity is intelligent and the rest of the universe is not. Although much of science has been about shortcutting computation done by nature, there seems to be a computational irreducibility to computation done by nature. Even with strong AI systems, there will be no shortcuts to get to the current state without going through all the computational steps. Also, how does one recognize if a system has a purpose? Does the universe have a purpose? Does computation have a purpose? Does intelligence have a purpose? How do we recognize purpose in strong AI systems, or for that matter, extraterrestrial intelligence?